All right, now that we've had some basic practice with just the plain formulas for the area of different shapes, we are going to be putting them together, and when we have different shapes melded together, or multiple of the same shape put together, is one figure that's called a composite figure. So that's what this first slide is over, is composite figures. Next, we're going to go through the shaded regions. There's going to be parts of it that are shaded, parts of it that are not, and we have to use our area and just logic to figure out what the area is going to be of just the shaded part. So in these first questions, we need to divide up the figures so we can see what types of shapes we are dealing with. So in this first one, I see it divided up like this. So if I look at each individual rectangle, then I can figure out what the individual areas are going to be and then add those together. I'm also needing to find what the perimeter is going to be of these figures as well. So if we want to do the perimeter first, we can. So we already have the 3 and the 2 and the 12 on the bottom. This little piece over here is going to be a 2, just like it's 2 on the right. We have our 5, the 4, but we're missing the top piece. And this little piece should be 4 because it's going to match the other side since it's a rectangle. And you have to look at the distance all the way across is 12. So if we already have 5 and we already have 3, that's 8. So the missing piece is going to be 4 at the top. So now for my perimeter, I can add up the different pieces. If I start right here and go clockwise around, I would have 2 plus 5 plus 4 plus 4 plus another 4 plus 3 plus 2, and lastly my 12 at the end. And I end up with 34 centimeters for my perimeter. All right, so next for my area, if I take the area of each of those boxes, this would be 10 because I have 2 times 5. For this one right here, I have 6, so 3 times 2. Those are the easy ones, so 10 plus 6. The one in the center, we have to look at, we have the width is 4, and the height, we have a 4, and we really have a 2, so together is a 6 for the height of that. So 4 times 6 gives me a 24. Then I'm going to add together with my other areas, and we get 40 centimeters squared. All right, for my figure over here on the right, I see this little piece sticking out, and if we kind of cut that part off, that makes it into a triangle, and then we have a rectangle for the rest of it. So for my area, probably the easiest thing is 6 times 7. I've got my 42 for the area portion. I'm going to do this out of order. I'm going to do my area first. Then I know that down here has to be 7, but all together has to be a 12. So that means the remaining part is going to be 5. And I know the whole height is 6, and this little piece is 3, so the remaining piece is 3. So for my area of the triangle, I'm taking 1/2 my base times my height. So that gives me 15, and half of 15 is, let's see, 7.5 is my area for that little piece. So if I add those together, 42 plus my 7.5, then I get 49.5, and this is millimeters, so it'd be millimeters squared. All right, so on for my perimeter, I have 6 plus the 7 at the top, plus my 3, plus I'm missing this piece right here, and then all of the bottom will be 12. So the part I need to find is the hypotenuse of this triangle. So again, I can do Pythagorean theorem to figure out what that hypotenuse length is going to be. So 9 plus 25 gives me a 34 equals x squared. The square root of 34 is 5.83. So that's what I'm putting right here as my missing length. So when I add those all up, we get 33.33, and this would be in millimeters. Don't forget to put your units after every single question. All right, for this next one, this is a pretty common picture you're going to see right here. And for the perimeter, there's a couple things we need to look at. So let's see, perimeter is in blue. So for my perimeter, I know that from here to here is 40, so that means the other side is 40. But I need to figure out this other distance. Well, if you think about it, these two halves make one circle. So I need the circumference of a circle, or really just one piece of it, is going to be half of the circumference of a circle. Remember, the circumference is 2 pi, and then the radius. Well, if the diameter is 20, that means that my radius is going to be 10. So that's going to give me the circumference of just one of my circles. And when I plug that in my calculator, I get 31.42. So that's going to be for both of them. So my perimeter, I'm going to take 2 of those perimeters or circumference of half of that circle and put them together, so that makes one whole. And then I have the 40 and I have the 40 from before, from top and bottom, and I get 142.84 yards for my perimeter. All right, so then for my area, if you think about it, this is a rectangle, right? So I've got my 20 times 40 for the middle section. And then I have the area of 1/2 of a circle. So I've got pi r squared. But I want 2 of those because I have 2 halves of the circle. All right, so if I plug all of that into the calculator, I end up with 1,114.16, and that would be yards squared. Okay, so I mentioned earlier that we're going to find the area of just the shaded region, so we have to think of in words first what the process is that we need to do. So in this very first one, if we want to find the area that's shaded, we have to find the whole area and subtract out the white. So we need to find the area of the large circle and subtract the area of the small circle. So my radius of my large circle is 8, so when we have pi r squared, I'm using my 8. The area of my small circle, I need the radius of the small circle, and that will be my 5. So pi r squared. So I get 64 pi minus 25 pi. And something you may not have realized is that because they're both pi, I can subtract the numbers in front of them, so the coefficients in front, and I get 39 pi. And then I can type that in the calculator, and I get 122.52, and that would be centimeters squared. So that's the part of the shaded region, the leftover part. So we want to do the same thing for the next picture. So we want the area of the whole figure, so that would be the circle. And we need to subtract the area of my triangle, since that's the white part of it. And then I'll be left with the shaded region. All right, so the number on your picture wasn't very clear, so that diameter is 16. So the area of my circle is pi r squared, so 8 squared again, so I get 64 pi. For the area of the triangle, remember we have to do 1/2 base times height. So my base is 16. But here's we have to think. If here's the center of my circle, my diameter is 16, that means that my radius is 8, right? Well, it doesn't matter where the radius goes, but if you notice, that right there is the radius, so that will be 8, and that ends up being the height of the triangle. So that's what makes this one a little bit trickier. So when I multiply these together, 1/2 of 16, I just get 8. And then so times 8, so this is 64. So if I take 64 pi minus 64, I get 137.06, and this is meters squared. For 2 last pictures, and it comes down to just practice so you recognize what the pictures look like and how to find them. We want the area that's shaded, so again we're going to find the area of the whole thing, so that would be of my rectangle. And I need to subtract the area of the white part, and that will be my circle. All right, so the area of my rectangle, we've got base times height, so my 18 times the 8. And then area of a circle, we have our pi r squared. Well, my radius is the 3, so this is 9 pi. And 18 times 8 is 144, so when I subtract this in my calculator, I get 115.73, and this would be inches squared, and that's the shaded region. All right, so same idea for the second one. So if I find the area of my triangle, so that's the whole thing, and I subtract out the pieces I don't want, so that would be the area of the circle, then I'll be left with the shaded part. So the area of a triangle, remember, is 1/2 your base, so my 36, times the height. Well, we don't have the height, so let's come back there. area of a circle then is my pi r squared. So here they did give us the 6, so this is 36 pi. Okay, so we need to go back and find out what this height is going to be. So I'm going to draw the triangle down here just to give us some more space. If you notice, there's a reason to give us that all sides are 36, and that's because we know that all the degrees then are going to be 60 degrees. So if I divide it straight down the center, that means that each of these are 30 and 30, which means that this piece is 18 and this piece is 18, so it's cut in half as well. So now look at just one of the triangles. Okay, so you could do this two different ways. We could use Pythagorean theorem with my 36 and 18 and my x to find the height. Or if you remember, with your 30, 60, 90 triangle, what the ratio is. And our ratio was x square root 3, and then we had 2x. So let me switch colors. So this was 2x. My shortest side over here would be my x, and then the medium side that I'm trying to find is x square root 3. So this is probably the easiest one. If my purple x's equal 18, I can plug that in right there. So that means that my height is going to be 18 square root of 3. So that's probably the fastest way of doing it, but if you do Pythagorean theorem again, you would end up with, let's see, we would have 18 squared plus my x squared equals 36 squared. In the end, we would have 972 once I subtract everything over, and then I take the square root of 972, and either way, you should get around, 31 point, let's make that a little bigger, 1/8 is what my height will end up being. So 31.18. So if we go back up here and we simplify this, the area of my triangle just by itself is 561.18. And then if I subtract out my 36 pi from that, I end up with 448.09, and this is centimeters squared.